Hi, my name is Steve Souders. I work here at Google on web performance, and I've started this new speaker series I call Web Exponents, and the tagline is raising web technology to a higher level. And so Nicholas is one of the first speakers in the officially named speaker series. I worked with Nicholas at Yahoo. He's a JavaScript guru. He's the author of Professional JavaScript, and I think co-author of Professional Ajax from Wrox, and he's also contributed a chapter to my next book, Even Faster Websites, which is coming out this month now. I have to start saying that. And he works on Yahoo Front Page, and he does this a lot, goes around evangelizing JavaScript best practices, especially focusing on performance. So I'm excited to have him here today and to present him with the official Google Tech Talk swag bag.
Nobody's taking a picture?
So please help me welcome Nicholas Zakas.
Hi. So that pretty much covers what I was going to say in my introduction. I usually start with this "who's this guy" slide, but Steve kind of covered it all, so I'll just go through it as if I'm saying it, because I don't really want to repeat. So anyways, here are the lovely book covers, and that's Steve's book over on the right, which I contributed a chapter to, out this month. Anyways, moving right along. The problem is that JavaScript is slow. Okay, we're just going to start out by saying that. And the secondary problem is that people notice that it's slow, right? Because a lot of the web is about perceived performance. And if your thing is slow and people perceive it to be slow, then you're in a lot of trouble. And there's a lot of complaints. I mean, this was just one of the things that I came across when I was looking for like complaining about JavaScript performance. But there's tons of stuff out there. And so we really need to be careful, especially now where people have really fast internet connections. 10 years ago or so, people expected the internet to be slow, and now they expect it to be fast. And that's mostly our fault for becoming really good JavaScript developers. But the browsers haven't really caught up. OK, so why is JavaScript slow? People who don't know anything about the web, they're usually like, well, there must be some sort of bad compilation going on. Which, of course, isn't true. The problem is that there's no compilation going on. And I have my little asterisk there in case anybody was just going to interrupt and say, but. We'll talk about that later. So really, the issue is that browsers aren't going to help you with your code. Right? They don't care that your code is running slow. They're not going to do anything to adapt for it. So really, if something has to be done to speed up your code, it pretty much has to be done by you. And so a show of hands, who thought that you would see a Smokey the Bear reference today? Yes, OK. So we're talking about JavaScript performance issues. There's a bunch of stuff to talk about, but in this talk, I'm going to focus on just a few areas. And I'm going to give you my regular disclaimer that these are things that you need to figure out if you need to do. I'm not going to stand up here and say, do this every single time, regardless of what you're doing, because that doesn't make any sense. Right? You need to take some measurements, figure out where the bottlenecks are, and then figure out if any of this stuff is actually going to help you in your job. So the few things we're going to look at today, first thing is scope management, which is something I think a lot of people don't understand. So we're going to dig into that a little bit. Data access, because where you put your data and where you're accessing it from can make a really big difference. Loops, it's everybody's favorite topic when it comes to performance, really. And then no performance talk can really be complete without talking about the DOM and how slow it is. So to begin with, we'll go with scope management. So this is a horrible, horrible function that I've written. Please don't look at it too closely, because it doesn't do anything interesting, and it really is just a bunch of stuff I threw together for an example. But it's a global function, set up, pass in some items, do some stuff, set up an event handler, get some DOM references, and then move on. But this is the basis for a lot of what I'm going to talk about next. So scope chains. When you define a function, and we're going to assume that this is the global function called setup that we just saw, there's this internal property called scope. And ECMA 262 has the little braces around it, but I don't know how to say that without it sounding weird, so we're just going to call it scope. And when the function is defined, that property is filled with a scope chain that has a bunch of information about the variables that should be available when that function gets executed. So when you have a global function like setup, there's only one item in there, and that's the global object that has stuff like window and document and navigator and a whole bunch of other stuff, but I just threw those in there to keep this reasonable. When a function executes, there's something called an execution context that's created. And that execution context has a scope chain of its own that it uses for identifier resolution. And the way that that's built up is the execution context is created. It takes whatever was attached to the function object's scope property, copies that into its own scope chain, and then creates an activation object that has all of the local variables in it and puts that at the front. So to take a look at what that looks like, hey, I just said that. Let's take a look at what that looks like. So we have an execution context that was created. Let's assume that setup is being called right now. This execution context has its own scope chain. So we start out by putting what was in the function's scope property there first. So that's the global object. And then we'll have this new object come in and get pushed onto the front, which is this activation object. And that has all of the local variables in it, which includes things like this and arguments, any named properties, and then any local variables that were declared in the function. So what happens is when the function is being executed and it comes across a variable, this process of identifier resolution starts. And it starts by looking at the first spot in the scope chain and then makes its way down to the back. So if it finds it in the first place, awesome, that's what it uses. If it's not found, then it goes on to the next place in the scope chain, and so on and so forth until either it's found or it's not found, and then you end up getting an error. In all cases, the last stop is always the global scope. So why do we care about this? The reason is that local variables are really fast to access, write to, read from, because they're in that first location in the scope chain. The further you go into the scope chain, the longer it's going to take to resolve those identifiers, and that can affect your script's speed. So charts, very fun. This is just a chart with some experiments I ran to see how long it took based on how deep into the scope chain a variable was. So across the bottom, we have how deep into the scope chain it is, and then across the side is the amount of time. And you can see that the general trend is that the deeper into the scope chain you go, the longer it's going to take in order to resolve your identifier. So we have a couple of really good performing browsers at the very bottom. You probably already know what those are, but we can discuss those later on. And then we have some kind of iffy ones in the middle, and we have some really poor performing ones at the top. And I'm guessing you can probably figure out what ones those are too, so later on as well. So this is just for reading from these variables. Writing from variables is not much different. Right? The general trends are the same. The deeper that you go into the scope chain, the longer it's going to take to resolve those identifiers. So a little bit more about the scope chain is there's a few things that will augment it for you. One thing is the with statement. And you've probably been hearing for years now, don't use the with statement. This is part of the reason, and I'll give you an example of that in just a second. The catch clause of a try-catch statement has the same effect, that it artificially augments that scope chain. And they both do that by adding an object to the front of the scope chain temporarily and then removing it later. So if we go back to the example from earlier, remember this is just the setup function that I had earlier in this presentation. And let's say that there was a with statement in the middle of it. As soon as execution flows into the with statement, you end up with a scope chain that looks like this. There's a variable object that's pushed to the front. So now that has all of your with block variables. And that means that all of the local variables to your function are now one step away in the scope chain. And that will affect your performance. So hey, I said that too. Local variables in the second slot. All the with variables are now in the first slot. So this is why Doug Crockford, oh, look, there he is, always says with statement is considered harmful. We should avoid it. Closures also enter into this conversation. The scope property of closures always begins with at least two objects, because it's going to be the global object, which every function has in there, but also the scope of the function in which it was created. So calling the closure means that at a minimum, you're talking about 3 objects that are going to be in the execution context scope chain when that's being run. So here's the closure in my earlier example. Very typical event handler, just thrown in there. And here's what it looks like. So that's my anonymous function. We have the scope chain. So push the global object on there first, because that's always in there. And then we have the activation object from the containing function. So that has all of the variables from the setup function that gets pushed on there too. And this is just the anonymous function object that has this. So then when you go to the execution context, immediately you have 3 objects in the scope chain. And that means anything that you're accessing from inside of the closure that wasn't defined there is going to take longer to access than the others. So some recommendations for this. Store any out-of-scope variables in local variables. It probably doesn't make much sense unless you're using it 2 or more times, because you have to take at least 1 hit to store it in a local variable. But if so, storing them in local variables can really speed things up. And that goes especially for global variables, because those always take the longest to resolve, since they're always the last spot in the scope chain. Avoid the with statement. It adds another object to the scope chain, and that means local variables are going to be slower to resolve. And be careful with try catch, because catch behaves the same as with. I'm not inclined to say don't ever use it. But if you have a spot that's always throwing an error and you expect it to throw an error, then there's probably some better way to handle this than taking the performance hit every time. Use closures sparingly. If you can avoid using them, you can usually save yourself some trouble. And then don't forget to use the var statement when you are declaring variables, because accidentally creating a global variable means that it's going to take longer to resolve. Was a question in the back?
Are you saying that even in the absence of any with statements or other scope changing things in the middle of the function, lookups are not cached? That every single instance of the variable goes through the same resolving procedure?
Right, so the question was, regardless of with and try catch, am I saying that these identifier resolutions aren't cached? Correct? I'm not.
So then why would caching a global variable in a local variable matter at all?
So it's a good question. I always say that my knowledge of JavaScript ends right where the interpreter begins. So I'm not entirely sure, going across all the JavaScript engines, what they're doing behind the scenes. All I am sure of is when I was running these tests, these were the results that came up. If anybody here works on Chrome and wants to fix that, please do. Yeah, so here's just an example, again, in the setup function, where I took a global variable, document, and just stored it in a local variable. And so I'm eliminating the number of global lookups here, which previously was 3, and now it's just 1. Again, this is really oversimplified example, but when you have a large amount of code that's accessing globals, you'll see a difference there. So next JavaScript performance issue, data access. There's 4 places from which you can get data in JavaScript, again, in general. One is your literal values, so your strings, your booleans, your numbers, null, undefined. Variables, of course, object properties, and then array items. And these all work kind of differently. So just generally speaking, accessing data from a literal or a local variable is always the fastest. And in most cases, the difference between those two is negligible. So you should feel free to use local variables whenever you want. The interesting thing is when you're accessing data from properties or array items, that tends to take longer. Exactly which one of those takes longer is really up to the browser. Different browsers have done different optimizations for this. And another beautiful chart. As you can see, the blue is a literal value. The red, if it turns out to be red for other people looking, at least it is for me, is local variables. Yellow are array items. And the kind of greenish, bluish thing is object properties. OK, and for the rest of you, it would be the bar on the far right that I'm referring to. And you can see the general trend, again, some browsers perform really well, some browsers perform not so well without naming names. But generally speaking, the literal and the local variables, the literals and the local variables tend to be pretty fast compared to property lookup and array item lookup. Firefox has done some interesting things to really optimize array item lookup, so that tends to be pretty fast compared to object properties. Some of the other ones, it's a lot closer, some not so much. But again, the general trend is that literals and local variables are faster. Property depth also matters. So if you have object.name, that will be faster to access than object.name.name, which kind of makes sense because you're doing 2 property lookups there instead of just 1. And the deeper the property, the longer it takes to retrieve. So again, little chart just to show, as you continue on, going further and further into objects, .name, things start to get slower and slower. This is a question I got the last time I was talking about performance, was if there was any difference between using dot notation and bracket notation to access properties. And there really isn't, except for Safari, which is kind of strange. It's the only browser where dot notation, you can actually tell that there is a difference between bracket notation. And that even goes up through like the latest Safari 4 betas. But in general, you really shouldn't have to choose between one or the other if you're concerned about performance. So some recommendations for this. This type of stuff you should store in local variables. So any object property that's accessed more than once, any array item that's accessed more than once. Try to minimize your deep object property and array item lookup. That'll help as well. So again, another stupid little function just to prove a point. I have a data object being passed in, and data.count is being referenced a couple times, data.item being referenced. I can change it around so that I'm eliminating property lookups here. So just by storing stuff in local variables, and if you want to see, like, does this actually make any difference in a few of the browsers here, Firefox, not that big of a difference, takes about 5% less time to complete. Safari takes about 10% less time to complete, and IE about 33% less time to complete. Probably not surprising, you tend to see the largest performance gains in IE when you're doing this sort of stuff. So next part, loops. Always very exciting. So we have a bunch of loops that are defined for us in ECMA 262 in 3rd edition. For in, do while, and then you can throw in the ECMA script for XML for each that Mozilla has. But really, when we're talking about loops, we're not talking about for in and for each, because for each, not used all that much, not implemented everywhere. For in, really inefficient if you're just iterating over a bunch of values in an array. So what we're really talking about in this context is for, do while, and while. And basic examples, I'm sure you guys all know how to write these. So which loop do you use if you want it to be the fastest? And I see this debate pop up every once in a while. And so the interesting thing is that it really doesn't matter which of these loops you use. So what does matter if the loop type doesn't? What matters is the amount of work that's done per iteration. And that includes the terminal condition evaluation and any incrementing, decrementing, or anything else that you're doing every time through the loop. And then the number of iterations. Right? And these don't change depending on which loop you're using. Right? You still need to worry about these. So if you want to fix loops, 2 really easy ways is decrease the amount of work per iteration, and then decrease the number of iterations. Right? Seems simple. In practice, not always so simple. But just for some examples here, again, the 3 different types of loops here. If you want to take a look at the things that are being repeated for each iteration, we have the terminal condition being evaluated each time. We have this incrementing being done each time. And then, of course, the body that's actually processing whatever value that happens to be. So some easy fixes. Eliminate object property and array item lookups. And just talking about this, if you're doing those every time through the loop, it's going to slow things down. So in this rewritten example, I've just moved values.length into a local variable so that each of the loops no longer has to do that property lookup each time through. So just replace those there. Next is try to combine the control condition and any control variable changes into a single statement. Because the best way to make things fast is to do less stuff. Right? Work avoidance is primary when you're concerned about performance. So if we look at this, in the terminal condition here, actually doing 2 evaluations, saying is j less than len, and then is that equal to true? And so if we can narrow that down so it's just 1 evaluation, things will end up going faster. So here I've just replaced those terminal conditions, basically flipped the loops so that they're going backwards, and counting down from the last item in the array to 0. And that means that I'm just going to have 1 condition to evaluate instead of 2. It's just, is that equal to true or not? And that tends to be faster. And in this case, it was up to 50%. It took about 50% less time when I rewrote it like this than the original one did. And that was across browsers. So things to avoid for speed. For in, because it's not actually just looking at the numeric items in your array. It's also looking at the properties, and it has to go up the scope chain, prototype chain. That tends to be slow. For each has similar issues. Again, not all that popular because not really implemented everywhere yet. 5th edition of ECMA 2.6.2 introduces this for each method on arrays natively. So that's also something to avoid. It tends to be really slow. And basically anything that is a function-based iteration, all the JavaScript libraries have them. These are just a few of the examples here. Those end up being really slow. So why? Most of them are set up kind of like this. This is the native implementation, where you pass in a function to a method. That function gets executed for each item that's in the array. And it tends to pass in the value, the index, and then maybe the array object as well. Problem is that you're introducing an additional function, and with it comes all the additional overhead of executing a function. And so the function requires execution. We have to have an execution context created, destroyed. We're also creating an additional object in the scope chain. In this case, because it's a closure, so anything that you're accessing from outside of that function, again, is going to be slower. And in most of the tests that I ran, this ended up taking about 8 times as long as just doing a regular for loop. So if you care about performance, you may want to double check any place that you're using function-based iteration like this. So the last thing I'm going to talk about today is the DOM, which you really can't talk about JavaScript performance without talking about the DOM. Or, as I like to call it, the DOM. Oh, come on. There was nothing for that? I thought that was great. The DOM is usually the slowest part of any of the JavaScript that you're executing. And there's a lot of reasons for this. Unfortunately, we can't go into all of them today. So I just thought I would pick a couple and show you what's going on. So the first evil part of the DOM that I want to talk about is the HTML collection object. And this is something that a lot of people just aren't aware of. So HTML collection objects live everywhere in the DOM, and they kind of do so insidiously. All of the collections that are on the document object are HTML collection objects. So document.images, document.forms, document.links, all that stuff. It's also returned by getElements by tag name and getElements by class name. So they're everywhere, very hard to avoid. So if you look at the DOM level 1 spec, this is the section that defines HTML collection. And you can find the evil part like right here in the spec. And since it's really small up there, I'm just going to bring it up for you. It says, note, collections in the HTML DOM are assumed to be live, meaning that they are automatically updated when the underlying document is changed. So, OK, that means that it's not a static snapshot. It means it's going to continue to change even after you have a reference to it. And this causes problems in a lot of ways. So this example here, I'm just getting reference to all of the divs that are in the document. And then for each of those, I'm creating a new one. So in theory, this should just double the amount of divs that are on the page. But in actuality, this becomes an infinite loop. And the problem is because HTML collections, again, are live, and they're being updated even after you've retrieved them. Divs.length is being incremented every time you're going through the loop. So you will never reach the end of that. So I is being incremented, that's great. But then I go in and I add a div. That automatically gets picked up in the HTML collection. And that means it'll just continue going on. I will never reach any limit in this case. So HTML collection objects, beware, they look like arrays, but they're really not. Like you can access the items using bracket notation. You can also access a length property, but they are not arrays. They do not inherit from the native array. They represent the results of a specific query that was run against the DOM. So if you consider the last example, we're basically saying, give me all of the div elements that are in the document. And if all of the div elements in the document change, then that's automatically going to be updated. And the query for this tends to be rerun whenever that object is accessed. And so it tends to be very slow. Again, generalization, I can show you there's my exceptions. So Opera and Safari have done some optimization for this so that they aren't nearly as slow. They're doing some sort of caching, but other browsers still are not. And so if we take a look at these two loops, the top one is just accessing an array, right, iterating over it, and there's nothing being done in the loop at all, right? I'm just iterating over the array. The bottom one, I'm using an HTML collection to do the exact same thing, right? And besides that, there's no difference between these two loops. So if you look at the performance across a few browsers here, what you find is that the bottom loop takes 15 times as long in Firefox, takes 53 times as long in Chrome 2, and it takes 68 times as long in IE. And so what is the difference here? That's the difference, right? We're doing items.length against a regular array, or we're doing divs.length against an HTML collection. Really, really slow. So in this example, I've rewritten it so that I'm storing the length in a local variable first and then doing the loop. So A little bit of a change there. But now, if I run these in various browsers, they end up being pretty much equivalent. Right? There's not much of a difference at this point because we're just doing one property lookup in each, and we've minimized the overall effect. So HTML collections, bad. HTML collections in loops, even worse. So what can you do? Minimize property access as much as possible. Store the length or the items in local variables if you're going to be using them a lot. The thing that you don't want to do is have a bunch of HTML collection dot all over your function. That's really going to slow things down. If you need to access items in order from that HTML collection frequently, and you would just like a snapshot, then you should store those in a regular array and access them there, because that will be faster. And this is just a function. I'm sure many of you have written something similar over and over. This is just a function that will convert something into an array. You can use the array prototype concat method in any browser except IE for this. In IE, that will throw an error, and then you just go through and manually copy over each item into an array. Once you have all of those elements in an array, it's going to be much faster for you to access that information. So next evil part of the DOM is Reflow. I didn't do the voice for that one because I didn't think you guys would like it. So Reflow, best explanation I found, Chris Watterson from Mozilla. Reflow is the process by which the geometry of the layout engine's formatting objects are computed. So what does that mean? It means that's how we figure out how big stuff is when we're trying to render it in the browser. And so when does reflow happen? Well, necessarily it happens on initial page load to make sure that your page looks the way that it should. It happens when you resize the browser, especially true if you have a layout that flows. It happens when DOM nodes are added or removed, because that may affect the layout in some way. It happens when layout styles are applied. And it can happen when layout information is retrieved from the DOM. So initial page load and browser resize, there's not a lot we can do about that. Right? That is going to happen regardless. So we'll skip over that, and let's talk about when DOM nodes are added or removed. So another really bad example is just adding a bunch of items to a list in the DOM. So creating a bunch of li elements, setting inner HTML on them, and then appending them to the overall parent. So reflow in this case will happen every time that append child is being called. It's updating the document that you're seeing. And so all of these calculations have to happen at that point in time to make sure that things are updated appropriately. So to the rescue, my friend DocumentFragment. A document fragment is a document-like object, except it has no visual representation. Right? You can never add a document fragment to your document and display it to the user. It's just a construct that can be used behind the scenes to make your life easier. It's considered a child of the document from which it was created. Child is probably the wrong word for that, but the document that created it is considered to be the owner of that document fragment. And when you pass a document fragment into add child, instead of adding itself, it adds all of its children. So it's a really easy way to build up a bunch of stuff to be added to the DOM and then add it at a later point. So I can rewrite this code to use a document fragment. You create it by saying document.create document fragment. And here what I did is, instead of adding each of those items onto the list itself, I'm adding them onto the fragment inside of the loop. And there'll be no reflow there because you're not actually updating the visual representation of the page. Where the reflow will happen now is just once at the end when we go and add all of those onto the list. So I've basically limited the number of reflows in this example to 1, where before there was 10. And that will end up being much faster. So another time when reflow happens when layout styles are applied. And layout styles are usually stuff like height and display and font size and width. If you change something from block to inline, vice versa, all of these end up causing reflow. So what can you do about this? You want to minimize the number of times that you touch the style object. Right? If you need to make a bunch of changes all at once, then the best thing to do is to define a CSS class that has all of those defined, and then just change the class name property. So if I rewrote that, and I just defined a class called active that has all that information in it, and I change class name equal to active, that causes 1 reflow instead of the 3 that we had before. And I'm just a big fan in general, especially for maintainability purposes, to do this as well, because it can really get hairy if you're touching the style object in a bunch of places in your code. So hey, reflow right there. So the last point where, Steve, do you have a question?
But what if you didn't know the style ahead of time, so you couldn't define a rule like that? Is it bad to do all the style changes through CSS text? Is that not good?
So okay, the question for anybody that didn't hear it was, if you didn't know all the styles ahead of time, would it be still okay to use CSS text to set it instead? So the answer is yes. As long as you're grouping things together, that will just cause 1 reflow. What you just want to avoid is, style.left equals whatever, style.right equals whatever, and doing them one by one like that. But CSS text is another valid way to go. Yes?
Does it mean you can change continuously, like say you're moving an object across the page? Is there a good way to do that? I'm actually writing that code right now.
So the question was, if you're changing a style continuously, such as moving an object across the page. Yeah, is there a really efficient way to do that? Unfortunately, I don't think so, because and I'm going to just state my bias up front. I really don't like animation on web pages, but it is one of those things where you really can't, if you want to move something left or right, there's nothing else you can do aside from setting left periodically at some regular interval that moves it across. What I would try to minimize is the number of other dimensions that you're animating at the same time. So if it's possible to just go left to right and not need to go up and down and in circles, that will tend to be faster. But the more properties that you end up changing, then the slower it's going to end up being, until browsers optimize that sort of stuff. Any other questions about that? There is.
Yeah,
yep.
Well, actually, it's about the previous thing, document fragments. If you have if you're doing manipulation within a table, which is what I'm doing, and there's you're inserting one element, but then you might want to change the others, like alternate row colors. Is it effective to then copy the entire thing, or take it out of the DOM and put it in a document fragment, and then put it back, or how would you?
Okay, so the question was, in the case of working with a table, if you're removing a row, adding a row, what's the best way to deal with that? Document fragment is just one way of doing that. Really, if you remove an element from the DOM so that it's just not being visually represented anymore, you can do all the changes that you want and then add it back. So you don't need to attach something to a document fragment in order to do that. If you wanted to, let's just say, for example, you wanted to remove one of those rows, do a bunch of stuff to it, and then insert it back, you could say, remove child, pull it out, do all of your work on the DOM node while it's not part of the DOM, and then add it back, and then you'll only end up with 1 reflow. Yep, sorry, 2 reflows.
Simply setting display none.
So setting display none will work as well. I tend to be more of a fan of just removing things when I'm working on them, but there's no reason why display none wouldn't work as well. The only thing to be careful of is how much that ends up shifting your page. which I guess would be the same for removing a DOM element anyways, so do that too.
What about visibility none?
I don't think visibility none would work. You mean visibility hidden?
Hidden, sorry.
Yeah,
Because then you wouldn't reflow the page, but you also do.
yeah, it depends on what you're doing, because with visibility hidden, you're still reserving the space in the page. So if you hid stuff, but then like you changed the height and it ended up pushing it up, then you would still end up with a reflow. Thought there was one more.
So display none would be the same as removing it. It would still prevent the reflows within the not displayed element.
Yes, display none helps a lot when you,
So I discovered a few years ago in IE, I forget if it was 6 or 7, that we took the displayed none approach and we made some changes. And even though elements have display none, IE would still take action on it. In this case, we were setting a background image, and it would normally background images aren't downloaded until their element is actually visible. And even though the element was display none, IE would start downloading the background image. So our page was slow because we were downloading all of these background images when we thought the elements actually weren't going to have any effect, but they were in the DOM and IE ignored display none. So I think removing them and then adding them back is actually better.
there you go, from the performance guru.
Did you do any measurements of across browsers of different length prototype chains?
I did, but I didn't include it in this presentation. But generally, the prototype chain issue is similar to the scope chain issue. Is the longer your prototype chain is, and the further into that prototype chain that you need to go, then the slower the retrieval of the property is going to be.
Did you have the same pattern of winners and losers?
Yes, that pattern didn't change very much, regardless of what specific performance issues I was measuring. Trying really hard not to pick on any particular browser.
Too late for that.
So the last time that reflow may occur is when layout information is retrieved. And I say may occur because at times during the life cycle, the browser may cache up a few reflows and wait to do them. And if you're trying to access some layout information, that may trigger the reflow immediately to make sure that that layout information is correct. So a few of the things that may end up triggering reflow, such as offset width and scroll left, and then accessing information from get computed style. And those can all end up causing reflows if things are cached up ahead of time. So again, not every time, but something to watch out for. So if you're going to be using that sort of information, certainly if you're going to be using it multiple times in the same function, you should try to minimize that by storing stuff in a local variable and then using that instead, just to make sure that you're not going to be triggering reflow by mistake. So again, some of the stuff to speed up your DOM, be careful when using HTML collection objects. Perform the DOM manipulations outside of the document if possible. Change CSS classes, not CSS styles, and try to group those changes as much as possible. Be careful when accessing layout information, because that may trigger a reflow as well. And really, the overall message is just be very careful when you're touching the DOM, because it can affect your performance. So usually when we're talking about performance, a lot of people are like, oh man, if browsers would only be better, then we wouldn't have to worry about this. Like, is this going to be forever? And the happy answer is no. So we have a few browsers making a lot of headway in this respect. So a bunch of browsers with optimizing engines. You may have heard of this Chrome browser that has V8 in it. There's also Safari 4 with its Nitro engine. There's Firefox now 3.5 with TraceMonkey. Opera is also working on one. Unclear if that's going to be Opera 10, Opera 11. But the cool thing is that they all use native code generation, and just-in-time compiling to achieve faster JavaScript. So finally, we'll have all of the optimizations that compiled languages have. And you already saw that in the charts that I was showing earlier, that the more modern browsers, their performance just blows away the older browsers. So hang in there. Hopefully it shouldn't be too many more years before we're out of this mess. So just to go over what we talked about today, mind your scope. Scope chain management is important. Local variables are your friends. You can use them all over the place. Function execution comes at a cost, so be careful of that. Keep your loops small as much as possible. And avoid doing work, which is what I try to do not just in JavaScript, but in life. Minimize the DOM interaction as much as possible. And of course, use a good browser and encourage others to do so. So, questions? Anybody? Whoa. Okay, so that was more of a statement, not a question, but that's okay. Yep.
So I'm kind of wondering about. Oh, sure. I have a booming voice, though.
He does. You should be up here.
So I'm wondering about the scale across the different things. So for example, I want to access this DOM object a lot. So do I do it once globally as opposed to doing it a bunch of times locally?
Can you repeat that again?
So let's say, for example, I want to get at a DOM object, and
yes.
I could do it once globally, just at the top of my JavaScript. I could say, var foo equals get element by ID, blah. And then in each function, they can access it. Or I could say, well, gee, you told me that I should use local variables, so maybe I'll just do it locally and not keep accessing that global variable. But now I'm calling the DOM 10 times or across 10 different functions. Does that make sense?
Yeah. So I mean, it really matters where you're seeing the bottleneck. So that's what I started out with. Right?
I was assuming maybe a DOM access was a magnitude slower than a global scope access.
Oh, I see. So really talking about DOM access versus accessing global variable. Yeah. Again, it kind of depends on what sort of effects that you're seeing as to what approach you want to take. Usually I recommend that if you're going to be accessing any DOM element multiple times, that you store it somewhere other than just on the DOM, whether that be in an object property or a local variable. That can be up to you. I usually don't recommend storing it in a global variable, just because then you still have to have that extra step up the scope chain in order to resolve that identifier. Does that answer your question? Okay. Steve.
Yeah, I had two questions. I'm embarrassed to say I've never used create document fragment before. Is that supported across all major browsers?
Yes, create document fragment is supported across all major browsers.
And then a bigger question is, that comes up a lot with these types of performance optimizations, is a lot of times it's hard to get the correct prioritization of tasks like this compared to other things like UI changes or new features. Do you have any success stories or case study feedback about how these techniques were applied and what kind of huge or marginal impact it had on the site?
Yeah. Unfortunately, I don't have a lot of recent anecdotes I can add because of the nature of my work recently. But when I started at Yahoo, I worked on My Yahoo, which is the personalized homepage product. And we were rebuilding it from scratch. And we did have some performance issues initially. And a lot of this stuff ended up applying. The major things that we found were cutting down on DOM interactions were what helped to speed it up. And when I say speed it up, what we consider to be the most important thing was really the user's perception of how fast the app was. And so initially, we go out with a few beta users. People say, oh, it's slow. And I say, OK, so what can we do? So we went back and looked over the code. And what we found, one major thing was that we had a ton of event handlers attached to the DOM. So as you were going around the page, there was all kinds of stuff that was happening. And that tended to slow down the overall page interaction, and that really annoyed people. So we went to event delegation, which unfortunately I didn't have time to talk about today, but it follows along with the touch the DOM as lightly as possible theory, is that when we reduced the number of event handlers that we had on the page, when we stopped doing animations, as the gentleman mentioned earlier, you're just doing style changes all the time. We removed what I consider to be gratuitous animations. All of the performance complaints started to slow down. Right? I mean, there's always somebody that's accessing it over some modem somewhere that thinks it's slow. But generally speaking, the biggest bang that we got for the buck was managing our DOM more effectively. We did end up going back and optimizing a bunch of the loops that were in the product as well, because there was a bunch that was going on when the app was first starting up. But again, really the biggest thing was just dealing with all of the DOM issues. Yep.
So the moral is put in lots of gratuitous animations in the beta and then take them out and everybody will be so happy they won't bother you thereafter?
Yeah, it's incredible how well that works.
One question
Right.
about the global variables.
Yep.
Do you think it's a better idea to use some like static variables instead of a global one? For example, if I have like 20 global variables, I split them into like 3 groups, and for each group I create a global class. But for each variable, I define them as static members of each individual class. Would that improve the speed?
I think the problem there is that you're then invoking the property access performance penalty as opposed to just accessing a regular variable. So I'd say whenever possible, trying to keep stuff that you're using frequently in variables is a better way to go versus storing it on a property, regardless if it's a static property on a constructor or a property that's on an object somewhere. Sure. Any other questions? Yep.
Excuse me. How do you do your benchmarking for across browsers you?
So I built a page that is essentially just a performance test suite, and go in and I have a bunch of different tests to run, and then I specify how many tests, and it just kind of goes off, automatically times it, with all the caveats that come with using a date object for timing per number of iterations, and then it does that a number of times, and then takes the average. I can, after this is over, I can send some URLs to Steve if he wants to distribute it out, if you want to play with it yourself.
And then the other question I had was, it sounds like for each, and when you were talking about the for loops, that all of these things are coming in future versions of JavaScript or ECMAScript, and they slow everything down. So like, why are they putting them in, or why do they encourage people to use them if it slows it down, if it naturally slows it down?
I think that there's a difference between encouraging people to use them and providing them for people to use. Because there are a lot of people that write JavaScript that aren't all that interested in performance, and then these become convenience methods for them. We can get into a long conversation about for each and why that was interesting and necessary for ECMAScript for XML, but the array.forEach, it's one of those things that people seem to have been clamoring for, and I think the evidence of that is that it's in every major JavaScript library, and if we implement it natively in the browser, that's going to end up being faster than any of the library implementations. So you could argue that we're doing a little bit of help to the JavaScript libraries in terms of performance. But I don't think that you can say just because it's there that we're encouraging people to do something that's slow, because if what you really care about is usefulness, then they're incredibly useful. If what you care about is performance, then not so much. But you could say the same thing about like, why was the with statement ever put in if it is so horrible and people have been saying not to use it for so long? At some point, somebody thought it was a convenient thing to put in, and so it's there.
Hi, are there any good JavaScript profiling tools that will tell you which parts of your code are taking most time?
Well, Firebug is, of course, the obvious one that does pretty well. WebKit has a new profiler that is kind of slick. You should check that one out. YUI has a profiler utility, but it's targeted, so you need to say specifically, I want to profile this function, and then go and run that versus just a general profiler. But those are the three that I tend to use. I haven't messed around with the IE8 one yet. Maybe I'll go home and do that today. But generally, those are the three that I use. Okay. So I give my closing. If you want to contact me at all, there are the various places to do it. And then all of the beautiful images here, Creative Commons. So that's it.